All right, folks, my name's Chip Johnson. I'm with Crown Battery. My title with the company is Regional Sales Manager, and I cover the western part of the U.S. for Crown Battery. Got involved with the renewable energy storage side of this about 8 or 10 years ago. Just like probably the rest of you here, it was a heck of a learning experience for me. I've really come to appreciate the industry, though, over the past 8 or 10 years I've been into it now. And we're just here to talk a little bit then about the end of life of the battery storage side of it when it comes to the renewable, and what the facts are and what we can offer from our side, as well as what some of our competitors are doing these days as well. So basically what it boils down to is I want people to understand, coming away from this presentation, what the actual facts are of what happens to the product as it reaches end of life. And with the various chemistries that are in the process that are available today to the marketplace, there's a lot of wide-ranging things that happen with the product at the end of life. And I just want to make sure the folks here have all the basic facts of what's going on with the product once it comes to its end. The gap between these various chemistries is still being closed to some extent, and we're still trying to get the information out so that you guys can make the proper decision on what to do. Obviously, the benefits of recycling: best way to protect the environment, conserve resources, and reduce our carbon footprint. But some of the things you need to understand is what the scope is then of what the recyclability is for the various storage energy devices that are out there today. Nice graphic here for you folks. On the lead acid side, 99% of the product is recyclable, and then 99% of all lead acid batteries are then recycled into new product for energy storage devices. By far the best in the energy storage industry. And as compared to lithium ion, with 0 to 60% of the product currently available for recyclability, and then of the actual battery itself, literally 5 out of 100 batteries are currently be recycled into new product today. So who here, when you purchase a renewable energy system, is buying the system for green? Green? I can't think of a more green solution for regenerating energy that when the product actually reaches the end of life, that you then can take that product and turn it into a new energy storage solution. Of any product that you can think of in the North American marketplace today, aluminum pop cans, or soda cans as we call them back in the Midwest, newspapers, any other product that you can think of, by far, the most recycled product in the North American market is a lead acid battery. And the nice thing about the lead acid product in terms of recyclability is that it has been an infrastructure has been in place to address the end of the life of the product for the last 50 or 60 years. It's nothing that we had to create recently or still in the process of building. The product and the infrastructure itself to recapture the materials of the spent product are currently in place, and there's an industry that revolves around the capture of that spent product. So we have two different types of recycle: the recyclable portion of the product itself, and then we have the portion of that item that is currently recycled, the amount of that particular product that is currently recycled. When you look at a lead acid product, when you look at the electrolyte within the battery, you look at the lead plates under the cover of the battery, you look at the plastic case itself, 99% of all that material can be recaptured at end of life and then used to build new plastic cases, put new electrolyte into the new batteries, as well as put the lead plates back into the battery as well. One of the emerging technologies on the marketplace today with lithium ion is that the recyclability rates range from 0 to 60%. And the primary problem that we're seeing with that marketplace today is that there's just not an infrastructure that addresses the end of life of a lithium type product at this point. And when you get to the point, if we get there, it then becomes a question of how much of that product can be recaptured for use in the building of new product. And the jury, quite frankly, is still out on that. And that needs to be determined by the industry, and it needs to be determined by folks who are making the purchase of the product based on true facts and figures, and not so much on the hype of the product or other things that are driving particular products to the marketplace. So closed loop recycling versus downcycling. Essentially, this gets back to the 99% of the lead acid product that can be recaptured to build new batteries. In terms of closed loop recycling with lead acid, by far the tightest closed loop of any product in the marketplace today, much less energy storage devices, versus products such as a lithium ion product that we call downcycled, where they're not captured and be able to put into new product and built with new energy storage devices. So Mark was talking earlier today about some of the stuff he's dealing with his renewable energy system as well. And Mark has a bank of lead acid batteries that he's been using for 24 years now from the longevity standpoint. And then when he's got an end-of-life solution for that product on the recycling side, it will be available for his product. What we're trying to demonstrate here with Mark's system is that on the longevity side, or the lifespan of the lead acid product itself, we can get to those kind of numbers that the other industry competitors of ours are promoting. It just requires a little bit of education and knowledge on the product itself, so the folks who are using that product understand what it takes to get 23, 24 years out of a battery bank. The reason that lead acid has become such a recyclable item is because it's affordable, and there's a market for it. With the vast amount of lead acid products sold in the marketplace today, both under the hood car batteries for internal combustion motors, as well as for energy storage, all of that product is captured, and we're literally talking tens of millions of batteries a year that wind up spent in the North American market. And because of that vast amount of availability of the spent lead acid product, there's been a whole infrastructure that's developed around the fact of recapturing the materials out of that product and putting it into a new battery. The reason it's been able to, from a standpoint of the industry being viable, is that it's very profitable for the recycling facilities to do this type of a procedure. So in the end, the recyclability of the lead acid product is a win-win situation, not only from the folks looking for a true green source on energy storage, but also from a standpoint of a very viable business plan in the North American market. The other thing with the lead acid product as well is that since it's an industry that's been around for 150 years, the industry of building lead acid batteries as well as recapturing the spent lead acid product on the recyclable side, it's a very well-regulated, well-watched over industry. So we don't wind up with a lot of issues with the product downstream from various landfills, various contamination issues, because the years have been spent on developing the industry to make sure that we capture all the aspects of the battery. So what we're looking for is that as a competitor and a supplier of lead acid batteries to the marketplace, we're asking our competitors to step up. The guys who are offering alternative energy solutions these days in the marketplace, we welcome the competition, but we also want to make sure that we're standing on a level playing field with those folks so that when they have an end-of-life issue with their particular product, they're going to be beholden to the same types of applications and the same types of regulations that we are in the lead acid world. And what we've been seeing so far is that that standard hasn't been held to some of the other alternative energy storage solutions that are out there today, and that needs to be a consideration that the renewable energy market needs to make for themselves as they're purchasing their own various energy storage solutions. The byproduct then of not having a recyclable industry for alternative energy storage solutions is that disposal fees become a very important part, or become a high part of the disposal of the spent battery at that point. If there's no market that wants that particular product when it's done, then at that point it becomes a drain on the customer who has purchased that product and is utilizing that product to get rid of it. And that always entails the use of some type of extra expense for the customer of that particular product at the end of the life of the product. We've addressed that decades ago with the lead acid world, and in fact what I would tell you is that when it comes to the spent lead acid product itself in particular, there's a market for that product where those batteries can actually be sold, and extra revenue for the user of that product can then be derived. So why is the lithium ion product rarely even downcycled? Well, first and foremost, it's unprofitable, and it also lacks the infrastructure, which we've talked about here a couple times already. Understanding that everybody likes the new and cool things that are on the marketplace today, as I do myself, what I would tell you is that there has to be the closed loop system of the product itself, so that when it does hit end of life, there's a place for that product to wind up at other than in a landfill or contaminating some other type of property where that battery is just basically decomposing in the field. I'm just going to read this verbatim because I think this is an important point we need to make here. Because the lithium-ion battery industry lacks a clear path to a large-scale economic recycling process, battery researchers and manufacturers have traditionally not focused on improving recyclability. They've instead worked to lower costs and increase battery longevity and charge capacity. And because researchers have made only modest progress in proving recyclability, relatively few lithium-ion batteries end up being recycled. So I guess the question becomes then, is it where does that product typically wind up at end of life? Not where we want it, okay? The other thing that's affecting it right now as well on the hybrid side with the electric vehicles, there's a huge influx of alternative energy storage solution devices that are going to be coming up that are going to need to be addressed, and we need a solution for that. And us folks on the lead acid side, just as much as anybody else out there looking for a green solution, want to see that solution. Part of the solution is to getting the batteries to last longer. Well, one of the things that we've taken a hit on in the lead acid battery world is the fact that there is a perception that our product doesn't hold up as long as some of our more newer competitors to the marketplace. And we have a lot of cases in the marketplace that we can reference that with proper care, some proper maintenance, and a little bit of education and training for the folks who are using a lead acid energy storage bank, that we can hit those numbers that folks are looking for from a return on investment standpoint, similar or even better than what some of our alternative energy folks are currently offering in the marketplace today. It just becomes a question of trying to get that information out to the people who are actually using the energy storage solutions and making sure they have the proper training and the proper knowledge and education to get the maximum benefit out of the product. So we strongly support then closing the gap when it comes to the recycling chasm that's out there right now between lead acid and other newer alternative energy solutions. All we would ask that as a builder of this particular type of chemistry for energy solution, you as the user of the energy storage device need to make the decisions properly about what you want to use for your particular systems based on the facts that are available and not so much about the hype and the headlines that are coming across the internet and various websites today.